Welcome back to Chemistry 2. We are on Unit 4, Chemical Kinetics, Lesson 2, Video 2. In this video, we are going to start looking at how we can determine what a rate law equation is going to be. So we're going to look at the same problem with two different methods for determining this. It does not matter to me which method you use. I prefer the logical method because it's shorter. But sometimes we cannot use that method and we're going to have to look at this mathematically. So here we are given an equation. A plus 2B yields C. Remember that we said that we can only look at experimental data to figure out what a rate law equation looks like. So in this, we are doing three different experiments. And we are varying the concentrations of A and B and calculating the rate of reaction. And you can see that in experiment number 1 and experiment number 2, A is kept the same and B is altered. And the rate changes. So we know that B, there's some influence of the concentration of B because if we change it and keep A constant, the rate changes. The same thing if we look at experiment 1 and 3. B we kept constant and A changes and the rate changes. So we're going to use this fact that we kept something constant and we can isolate one thing. So with the logical method, we're going to pick two experiments in which only one reactant changes concentration. And I am going to first pick experiment number 1 and 2. So in this one, I'm going to write that the concentration of A stays the same. So it doesn't change, so we're not looking at the influence of A on the rate. We're going to look at B. So if we look at B, it goes from 1 times 10 to the minus second to 2 times 10 to the minus second. So it doubles in concentration. If I look at the rate goes from 1.5 times 10 to the minus 6th to 3 times 10 to the minus 6th. It also doubles. So I can look at this and say, okay, 2 to what power is equal to 2? Because I'm trying to find out what is the order of B. So I know it can be 1, it can be 2, it can be 3. I'm trying to find out what that order is on B. So B doubled and the rate doubled. And in this case, X is 1. So I know that B is to the first power. Then I'm going to pick another set of experiments in which B stays the same and A changes. So I am going to pick experiments 1 and 3. If I look here, A goes from 1 times 10 to the minus second to 2 times 10 to the minus second. It doubles. B stays the same. So I can be guaranteed that any change in rate is going to be due to the change in concentration of A because B is not changing. If I look at the rate, it goes from 1.5 times 10 to the minus 6th to 6 times 10 to the minus 6th. Here, the rate goes up by 4. So if I know that A goes up by some factor and the rate goes up by 4, I know 2 to what power is equal to 4? 2 to the second tells us that the rate is proportional to the square of A. So I know that my rate law is going to start looking like this. Rate is equal to K times A to the second, B to the first. If I had C, D, E, and a lot of different reactants, I would just pick experiments in which only One reactant changes. And then I'm going to find K. So K is this constant, and we can only find K by using one of our experiments, our determined orders that we figured out, and a rate, and then we can solve for K mathematically. So I always pick the first reaction. So pick a reaction experiment and substitute all orders and solve for K. So I know that our rate is equal to K times A squared times B to the first. So if I pick experiment number 1, our rate is 1.50 times 10 to the minus 6 ms negative 1 is equal to K times A, which is 1.00 times 10 to the minus 2nd molar squared, because of the squared, times the concentration of B, 1.00 times 10 to the minus 2nd molar to the first. So I have to solve this for K. So this is just an algebra problem now. So to solve for K, I'm going to divide both sides by 1.00 times 10 to the minus 2nd molar squared times our B value to the first. That crosses these out and it leaves K by itself. This is where things get tricky. Make sure that you are putting these into the calculator properly. So when we do this, we end up with 1.50 as our number. And we have to worry about units because the units change based on reactant order. On top in the numerator, we have 1m. Down here, we have 3m's because we have this one squared. So that leaves us 2m's in the bottom. So that's m to the minus 2. And we still have our s to the minus 1. So s to the minus 1. So this is our K value. 1.50 m to the minus 2, s to the minus 1. So our overall rate law, I'm going to write up here, rate is equal to 1.50 m to the minus 2, s to the minus 1 times the concentration of A squared times the concentration of B to the first. So that is our calculated rate law. In the next video, we're going to use this same example and show you how to do this mathematically.